Welcome, everyone. Thank you for joining us today. My name is Marvin Lopez, and I'm the Director of Client Success at PointMan. Today's session is focused on a problem that impacts every utility owner, contractor, and public agency, utility line strikes. And more importantly, how modern workflows are helping organizations dramatically reduce risk after the locate, where most incidents tend to actually occur. Today, we'll be discussing how survey-grade RTK accuracy, when paired with real-time geospatial utility mapping, can move organizations away from static, siloed records and towards persistent, trusted utility intelligence that teams can rely on throughout the full lifecycle of a project. This webinar is a joint session with our partners at JAVAD GNSS, who bring deep expertise in high-precision survey technologies. Together, JAVAD and PointMan are helping field engineers, construction teams, modernize how utility data is captured, validated, and shared without adding unnecessary complexity. We'll walk through why legacy workflows continue to introduce risk, what modern utility mapping looks like in practice, and we'll end with how organizations today are already seeing measurable improvements in safety, efficiency, and confidence in their utility locate data. I'll turn it over to Mike Waddell to get us started.
Thanks, Marvin. I do appreciate it, and I appreciate everybody taking the time today to join us here on this webinar. Like Marvin said earlier, we're here to talk about the reduced utility line strikes by possibly 97%. My name is Mike Waddell. I'm with JAVAD GNSS. I've been in the geospatial and sales support industry for over 30 years. I've worked directly with PG&E, SMUD, SDG&E for utility locating and for GIS data capture. Some facts and figures. Plus or minus over $200,000 is reported in damages every year to line strikes. It's actually upwards of $500,000 in actually damages each year after year, with $30 billion in social costs, deaths, disruption, these types of things. 10 to 12% of all damages are explicitly blamed on incorrect facility maps records. CGA states that the mapping issues are likely underreported. In 2022, supplementary analysis say up to 94% of the damages are related to inaccurate subsurface data, or GPRS. You can kind of see that through the graphics here on the slide. Who is JAVAD? JAVAD was founded in 2007, and we're a leading manufacturer of high-accuracy GPS and GNSS receivers. Headquartered in San Jose, California, as is our manufacturing facility, our R&D facility is located in Kentucky, and we have a global presence in an office in Lithuania. We design and manufacture professional positioning communication solutions with a full product portfolio. And you can see we serve a wide range of applications that depend on mission-critical performances when it comes to positioning and communications. We bring space tech to subsurface mapping. We at JAVAD like to say in the geospatial market, using high precision GNSS is not rocket science, but JAVAD, we do guide them. When it comes to utility mapping and solving huge problems of line strikes, we're bringing our field-proven, space-proven technology to subsurface mapping in an affordable package that fits in the palm of your hand. The Triumph T3NR receiver. This is a proven all-inclusive receiver, no external batteries to mess with, simple, intuitive LED displays that make pairing with PointMan software fast and easy. Our solution centers around the T3NR compact, lightweight receiver that packs a punch. As noted on the slide, we have a full GNSS IMU for out-of-level measuring, obviously compact, lightweight, one-button push, 25 hours of internal battery, Bluetooth, Wi-Fi, are USB capable. Not all RTKs created equal. Many GNSS providers claim RTK capabilities, but not are all the same quality, precision, and reliability. The next few slides will explain how JAVAD does RTK better than our competition, especially in difficult environments that subsurface locators often work in. This includes urban canyons and areas with dense canopy. JAVAD GNSS receivers are using patented algorithms to achieve centimeter level vertical and horizontal accuracies with an open platform for existing RTK networks. Let's take Caltrans, for example. That's the DOT here in California, where I'm based out of. They have a very extensive real-time network, and they want to use it. Well, most of our competition at this level of accuracy will make you subscribe to their proprietary network. JAVAD has an open platform with anti-spoofing and anti-jamming technologies. High precision RTK, centimeter level accuracies vertically and horizontally. Accuracies in real time, this is unmatched in the market. Most GNSS providers give you RTK solutions with at best 6 centimeters worth of precision at the same cost of a JAVAD system. JAVAD regularly solves positions with centimeter precision. No cell, no problem. No real-time network. Remember, we need an internet-capable signal to get our real-time corrections. This is a problem for utility lines in remote areas with no cell coverage. In these cases, we, JAVAD, offer JSTAR PPP service. JSTAR delivers corrections through the same satellite signal you're already receiving with your GNSS positioning. So you can continue to capture utility locations with high accuracies, even if you don't have an RTK network. Military-grade hardware. At JAVAD, we build our receivers to withstand the toughest job site conditions and weather conditions. Working in the field can be unpredictable. Sometimes bad things happen outside your control. JAVAD receivers, including the T3NR, are tested and complied with military standards for shock, vibration, and the IP68 protection. Your equipment will never be the reason that you leave the job early. RTK bundle. These are the 3 components of utility mapping solution: a receiver, our T3NR, your mapping software, PointMan, and a correction service provided by PointMan Nav for free for the first year. But remember, with JAVAD, we're not locking you into a specific RTK correction service. You can bring your own RTK corrections. This chart is of us and our competitors at centimeter level accuracies. You can see by looking at the chart here that we track more GNSS channels than anyone else. We have the centimeter level accuracies vertically and horizontally. We track all GNSS constellations. We have an IMU for mislevel measurements. We have an open platform for the RTK correction service, and we're made in the USA. For those of you who truly believe in supporting made in the USA products, JAVAD is the only manufacturer of GNSS receivers in the USA. Don't be fooled by assembled in the USA. JAVAD is truly manufactured in the USA. In fact, all of our receivers are manufactured in the USA at our headquarters in California by our sister company, JAVAD EMS. So we've been completely committed to building here in the USA and have been since 2008. For those of you who might be interested, we have a list of manufacturer certifications available upon request. If you scan the QR code here, you can see some of what we've talked about today, learn more about the utility mapping offerings, and get in touch with us. And with that, I'd like to turn it back over to Marvin to delve into the PointMan software.
Thank you, Mike. As you guys can see, JAVAD's no joke when it comes to high precision, right? And that's why we've partnered with these guys to be able to bring a really great product offering to the market that is low cost, low entry, and a low learning curve when it comes to using these technologies together. What I'd like to go into now is we'd like to build on that foundation, because while survey grade RTK accuracy is critical, accuracy alone isn't the finished product. The real question is what happens to that precision after the locate is completed. That's where most utility risk actually shows up, when data becomes static, disconnected, or difficult to trust across the teams. For those of you who don't know, PointMan is a field-first, cloud-connected utility mapping platform that captures, validates, and organizes geospatial utility data in real time. By using the incredible processing power of modern mobile devices and cloud platforms, PointMan turns RTK measurements into persistent, trusted utility records that can be shared across field teams, engineers, and office teams, and construction teams. Starting here, we're going to shift the focus from hardware accuracy to operational impact. We'll see how the precision data becomes persistent, trusted utility intelligence that field engineers and construction teams can rely on throughout the entire life cycle of a project. This is where PointMan and JAVAD come together, turning world-class GNSS positioning into real-time geospatial utility mapping workflows that reduce risk, improve safety, and scale across organizations. So with that, let's take a look at how combining these two platforms allow teams to do more with the accuracy they already have. Most utility risks don't happen during the locate, they happen after. Static records break trust almost immediately. So non-geospatial workflows, PDFs and all that, create downstream risk. And without a unified standard, data also tends to degrade the moment it's handed off. How many of you guys have heard this before? We've always done it this way. When I started in the utility industry, I swear I heard this almost every time I spoke to folks. And I still hear it a lot today, but less and less because of these new workflows that are beginning to be adopted. Although existing utility data forms the foundation of every modern city, the problem lies with how field teams make sense of all of that available data. The issue is then compounded when field teams and crews find it difficult to use that data that has been presented to them. Typically, an amalgam of various PDF printouts. That's if any utility data exists at all. Consequently, in the opposite direction, how does one accurately and efficiently collect, represent, and share that data from the field teams that can then be verified and processed by highly technical CAD and GIS teams waiting in the office? What this tends to create is an information bottleneck. Usually, this lack of direct communication leads to extended post-processing times of valuable utility data. For those working in construction, this also tends to work in conjunction with continuously having to call in field teams to relocate utility data that has already been marked out time and time and time again. So really what we talk about with PointMan and combining it with technologies like JAVAD is how do you take these technologies to surpass old workflows with new, more efficient workflows? This is the inflection point, really. Old workflows rely on specialists, post-processing, and siloed data. New workflows are real-time, field-first, and built around geospatial truth, not assumptions. As mentioned by Mike before, this isn't theoretical. The CGA estimates over $30 billion in annual damages, and many of those happen in the same corridors over and over again because bad data keeps getting reused. Obviously, this increases risk and decreases safety because the technical workflows lack geospatial intelligence a lot of times. Traditional CAD and GIS and survey tools weren't really built for utility mapping crews. They're complex, they're expensive, and they're slow at validation. Firms overpay for features and training technicians to use those features, not necessarily always needed for mapping and locating. That complexity can also increase assumptions about field data when you're translating that information over to the office crews, and that assumption increases risk. Why change now? The pressure is only increasing. Infrastructure funding, tighter timelines, higher expectations. At the same time, awareness is growing and legislation is starting to catch up. This is all starting to kind of escalate down the tube, right? As project density increases, post-processing becomes a liability. Miscommunication during post-processing can also lead to incomplete records. Additionally, every handoff between systems and teams is a chance for utility data to degrade. And real-time standardized workflows are now an incredible way to scale, but scale safely as utility projects increase and utility teams increase throughout the country. This is the side-by-side reality between old processes versus new processes. Legacy systems lock teams into proprietary ecosystems. That tends to delay data access. Modern workflows are more open. They're easier to learn. That means losing an employee is less of a risk factor when you can easily teach a new employee the technology and the processes that you're currently implementing. And synchronizing data instantly between field and office teams reduce post-processing times, create trust in the data, lets everybody essentially play on the same field of utility data that no matter if the field's working off of it or the CAD teams are working off of it, there's a singular unified source of truth that data is going into and coming out of. The operational advantages implementing these new workflows are really what we're here to talk about. When you combine RTK mapping with real-time validation, everything improves. You have increased safety. When you have photos, videos, paper records, all in a digital platform that anybody can access, whether it's today or years down the road, you're also giving yourself a little bit of legal protection in that sense. Bid competitiveness is another thing that you should probably think about, is if you can turn around your deliverables, if you can outpace your competition with better workflows that you can trust, then you're going to be getting ahead of the competition just by the mere fact that you're more efficient. Less errors in the data exchange also, and then of course the instant QA/QC processing. But this isn't really cutting corners, it's cutting waste. And that's what we're here to do, is talk about the efficiencies of how you can implement these technologies and cut waste out of the current modern legacy workflows that exist throughout the industry. So what do the results of these new workflows look like? Primarily, there is real-time validation that replaces delayed QA/QC. Field data becomes immediately actionable. You can now trust the data that's being collected from the field teams, and strike rates tend to collapse when trust exists. This controlled comparison that we're talking about and how reducing utility line strikes works is actually from a study that we did a few years back with technologies, PointMan, similar technologies for the surveying to get all of this information collected over a controlled time frame, a side-by-side comparison that were nearly identical projects, same city, similar 10-mile project scope. The only difference here was the workflows, an old legacy workflow versus today's new modern workflows. The outcome wasn't incremental, it was exponential. Before we get into the results, let's talk about understanding the risks and how they were calculated out. You can see here that this is an average cost per strike. This is according to the 2016 DIRT report, okay? With inflation adjusted, especially after the increase in inflation in COVID, these prices have likely gone up a lot higher than they currently are displayed here. The estimated downtime also is another thing that we should consider when you have a utility line strike occur. You have labor relocation. You're paying for labor that for people standing around trying to wait for whatever issue gets fixed prior to them being able to go back into this. That increases overtime payouts. You're also a lot of times perhaps renting out machinery, renting out backhoes and other tools, and those are just sitting there waiting for the incident to be resolved before they can get back to work. And of course, the potential injury or loss of life, which is another huge thing that could happen, and that's obviously what we're trying to avoid here is any type of injury or dismemberment. In calculating all these things together, what results of is these key takeaways from this project. At the conclusion of the project, when we did a side-by-side comparison, the first project that was utilizing the PointMan workflow had 3 strikes per year. With those strikes, it was so 344 versus 144. The way that this was calculated out was the average cost of utility strike, which we just showed earlier, plus the total cost of incidents times the number of utility strikes. On average, the total savings on just this project alone between side A and side B was about $4.6 million, right? That's a monumental cost savings that was done by implementing technologies like PointMan, like JAVAD, in a new modern workflow that allows for trust to be gained from field teams to office to CAD, GIS engineer teams, and all the way back downstream. Modern utility mapping isn't necessarily about new gadgets. It's about trust, right? Verification, continuity from the field to the office to construction and back. The main question that we're here to answer today, right, is how do you reduce utility line strikes? You remember that RTK accuracy alone isn't enough. Value is created when precision and data become persistent, trusted utility records. Modern utility workflows reduce risk after the locates. And as mentioned earlier, after locates is where most strikes tend to actually occur. Real-time geospatial data validation builds trust. It builds trust not only for one team or the other, but it builds trust across the entire team, the entire project, from the field teams to the engineer teams to the office and geospatial teams to the construction teams, and again, all the way back down. The standardization opens workflows and lowers costs. Not only does it lower cost, but more importantly, it improves safety without increasing complexity. So that's why we've teamed up with JAVAD to bring these new product offerings that is an all-in-one bundle that includes a mapping technology like PointMan, a high precision technology like JAVAD, to be able to give to folks who haven't had access to this kind of easy to use, easy to learn, really powerful mobile and cloud technology that can give them precision and actionable intelligence in their utility projects day to day, instead of having to go and track down highly specialized folks and technologies that can give them the same results, but with a lot more complex workflows in between.